Example 5.12. Carbon dioxide is also a molecular substance and is made up of carbon atoms and oxygen atoms. So what I need to do is I need to know how many of each type of atom there are in the formula. So there's one carbon and two oxygens. The formula is CO2. Now I need to find the number of valence electrons that are totally there. So I'm going to go to the periodic table, and in the periodic table you see that carbon is in group 4A and oxygen is in group 6A. So carbon has 4 valence electrons, oxygen has 6. I'm going to use my simplified periodic table. Here, okay, so carbon is in the fourth column over, 1, 2, 3, 4, group 4A, and oxygen is in the sixth column over, group 6A. So carbon has 1, 2, 3, 4 valence electrons. Carbon has 4 valence electrons, and oxygen has 6 valence electrons. It means we have one carbon atom, and each carbon has 4 valence electrons, 2 oxygen atoms, each oxygen has 6 valence electrons. So that means we got a total of 1 times 4 is 4, 2 times 6 is 12, 16 valence electrons to distribute in this compound. So I'm going to start by putting the atom that appears first in the formula, the carbon, as the first element, or as the central element. I'm going to put the 2 oxygens down on either side of it. Next, what I'm going to do is I'm going to connect the central atom to the outside atoms with a single line representing the sharing of a pair of electrons. To emphasize that, I'm going to put 2 dots on each of these lines. Each dot represents an electron and a chemical bond. Covalent chemical bond is when 2 electrons are shared between 2 atoms. So now what I need to do is I need to make the outside atoms happy. Well, the outside atoms are the 2 oxygen atoms. So I'll start with this one on the right. It sees 2 electrons, wants 8, so it needs 6 more. Got to give it 6. And that's the same deal over here. This oxygen sees 2, wants 8, needs 6 more. The carbon sees a total of 4 electrons around it. It needs to have 8 to obey the octet rule, so you have to give it 4 more. And now you do a tally. How many electron dots do I have down here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This structure that I've drawn down has 20 valence electrons in it. Can't be right. I only have 16 to distribute. So this thing that I've drawn down here, this initial diagram, let's call it a trial diagram, a trial structure. It can't work. What you do to use up 2 electrons is to add another bond. So I'm going to do that. I'm going to go back to blue. Here's my carbon. There's an oxygen. There's an oxygen. Connect them with a single line representing the sharing of a pair of electrons, and I'm going to add another one in here. And I'm going to add another bond. And I'm going to put electrons on the lines. So there's a pair of electrons. Pair of electrons. And now this oxygen, the one on the right, sees 4 electrons, so it needs 4 more. The one on the left sees 2 electrons, so it needs 6 more. And the carbon sees a total of 2, 4, 6 electrons, so it needs 2 more. How many dots do I have down here? I've got actually 18 electrons here. So that can't be right either. That also is a trial structure. Well, each time you add a bond, you use up 2 electrons. So I'm going to try this. Carbon with an oxygen and an oxygen. 2 double bonds. Here we go. And that's the term when you have 2 bonds in a between 2 atoms. That would be what we call a double bond in chemistry. Dots on the lines. That oxygen sees 4, needs 4 more. This oxygen sees 4. It's 4 more. Both oxygens now are happy. They see 8 electrons each. The carbon is happy. It sees 8 electrons. How many dots do we have down here? We have 16 electrons. So we have a happy Lewis electron dot diagram.